So then you go to the airplane company and said, why don't you develop an electric airplane so they can develop the batteries? And they would ask, I can't build an electric airplane. What engine do I use? So magniX started with the notion of you have to start with propulsion. Once you have propulsion, then we can do design. And we're seeing that today, like Aviation Alice, Heart Aerospace in Sweden, By Aerospace, Pipistrel. Once you have the propulsion, we can start looking at new aircraft design. Once new aircraft designs become real, battery companies will follow. Very similar to what we saw with electric cars. Before Tesla, electric cars were a novelty, and the only batteries you can really buy were the 12-volt batteries for car accessories. Then suddenly Tesla came and said, and people said, just like we hear today, there's not enough batteries, you won't have enough range, what will you do in winter? And so Tesla said, okay, we'll start with a niche, a converted Lotus car with a small electric motor and batteries enough for 50 miles and 2 people. And it started. Today, 8, 9 years later, my family has 2 electric cars. They can both take all 5 people of my family 300 miles, and I can charge them in an hour. It's in an 8-year process. We went from a niche and people saying that it will never work to now the same people saying, why do we need so much range? Why are people trying to get 500 miles out of a car? And so it's really flipped, and the same thing will happen in aviation. So who are we, magniX? Our purpose is to connect communities by enabling every person in the world to fly. And our vision is to become the world's most recognized and trusted company that powers on-demand, affordable, and clean air travel. Just kind of highlights. We've been doing this for quite some time. We are not a startup of the past few years of this niche of electric aviation. We started doing electric motors in 2009 in Australia is where we started. And we developed all sorts of different technologies to explore what would be the most applicable ones. We looked at superconducting motors, permanent magnet in the axial, radial flux, etc., different types. And in 2017, when we developed our first practical, I'll call it aerospace prototype, we pivoted the company, stopped doing R&D on different types of technologies and focused purely on aviation, and within that, commercial aviation. We do not do the air taxi, VTOL, we do not do 2-passenger trainers. We are purely focused on aircraft with the purpose of moving people and goods as a business, so commercial aviation. We are providing just electric propulsion. We do not do the batteries ourselves. We do not do the hydrogen fuel cell. We do not do the airplane, just propulsion. Very important to focus. We've seen multiple companies in general in my previous life in startups and in aerospace try to do everything. And when you try to do everything, as my grandmother once said, you do a little bit of everything and a lot of nothing. And so we decided to focus purely on propulsion. Our sister company, Aviation, focuses purely on fuselage. And for example, for cockpit, we buy externally. And so the idea of successfully being in a startup is what we have found is that focus on an expert element of the technology is what allows us to succeed. And to that end, we are already on the path to FAA Part 33 certification in the first half of 2022. Our rules have been approved by the FAA, so they've written the rules for our electric propulsion. They have published them at the end of last year, and we are on track for 2022 certification, which means it can then be a certified propulsion system on any aircraft, which is very exciting. And then just in terms of facility, we just recently opened a new facility in Everett. Basically, we have encroached in the hometown of Boeing. And some people ask if we are next to Boeing, and I like to say, no, Boeing is next to us. So it's a matter of perspective. But we now have there, I'm going after this, I'm going to go back there. That's where we're now doing the design, build, test facilities inside the building, etc. So very exciting time. In terms of the propulsion itself, this is real. As opposed to a lot of other companies that have these great designs and videos of what flying airplanes might look like in the future, we have a very practical approach, which is go fly. Unless you fly something, not a drone, not a scaled down version, unless you fly the actual airplane, you're not an aerospace company. That's what I told the group when we started this. I said, we will become an aerospace company when we fly the actual plane. Then we will be in aerospace. And we've already flown 2 and continue to fly them. The first was in end of 2019, so a little over a year ago now, when we flew the E-Beaver, the aircraft you see on the top right here. That's a 6-passenger airplane. It's a seaplane in this case, flown by British Columbia's Harbour Air. They're the world's 2nd largest seaplane airline, and they fly everywhere around British Columbia. And then in May, just this past year in May, we started flying the 9-passenger Cessna Grand Caravan. Of course, the Caravan is a workhorse of industry. Everyone knows that plane. And we now recently launched an STC program with Sydney Seaplanes, who is going to do the Cessna Caravan. So we're very proud to be the only company in the world, in fact, to have flown, designed, built, and in fact flown and continue to fly real commercial propulsion systems. And when I say commercial, it's really about size and power. Our smallest motors are 280 kilowatts. The ones flying these airplanes are 640 kilowatts for max takeoff weight. And these are on the way to certification. So these are aerospace designed propulsion systems, motor, inverters, power electronics, etc., that were designed to fly airplanes at high altitude, unpressurized, etc. And we can talk about this more if you want. This is just a quick, I won't go through this, a quick storyline of where we started, 2009, again, starting in the industry, and then some key elements. In 2019, we spun the first propeller on their large propulsion system. In 2019, we started flying. 2020 added the Cessna Caravan, and then recently some new announcements that are exciting that we can talk about later as well. In terms of why is electric propulsion even worth talking about? Now, since you're talking all about electric propulsion, you'll know this, but some key features that I think are worth mentioning. Power density is, of course, really important, but it's not just power density of the propulsion system. The fact that our electric propulsion system does not require air means that hot conditions, high altitude conditions are not an issue. Today, turbine engines, jet engines, internal combustion engines, pistons, have a problem as they climb to altitude, especially the pistons and the turbines. So the higher they climb, the more air they need in order to create thrust, the less air density there is. And so from that perspective, they lose power. So you need a really powerful engine on the ground in order to fly efficiently at altitude. With the electric propulsion system, you don't need that. So we can use smaller powered propulsion systems on the same aircraft and get the same power at altitude. And so from that perspective, it's an advantage, less weight, less cost on the aircraft. Efficiency, of course, is much better, 93% on our systems in time. I'm not talking motor. The entire system is already at 93% versus around 35 for turboprops. Much quieter. We did some measurements that will soon be made public, but we did some measurements on our Beaver versus eBeaver, and it's 40% quieter. Half the noise almost, which is tremendous if you think about sitting in a propeller aircraft or being outside of a propeller aircraft. Imagine what that means, being half the noise, flying in and out in the evening or early morning, airports that are closer to the towns. So from that perspective, a huge advantage. High levels of reliability, as opposed to thousands of degrees of temperature, you're working at a little over 100 degrees Celsius of temperature, one moving part and not hundreds of moving parts, no friction, no oil for lubrication. And so from that perspective, the reliability of electric motor is very high. I talked yesterday to a group of students, and I kind of, in order to compare, I told them, when's the last time you had to take your regular car to service, change the oil, change the filter, change the spark plug? Every 3,000 to 7,000 miles, you have to do that if you have a regular car. So when's the last time you took your washing machine to service, or dishwasher, or mixer, or blender, or if you have an electric car, your electric car? There's nothing. You have to rotate the tires, but that has nothing to do with the propulsion. And so airplane maintenance may continue, but the main part of maintenance, which is the engine, almost disappears. And then, of course, lower operating costs. Because of the engine and the fuel aspects, much lower operating costs, which then means either higher profitability for the airlines that then translates into lower ticket costs and more services. When you don't have to buy a very expensive 70-passenger, 110-passenger plane to do short routes, and you don't have to spend $2,000 to $3,000 an hour to operate that plane. Rather, you can spend $400 or $500 an hour. Maybe you can do more flights. Maybe you can do more flights from and to more airports and offer lower ticket prices. A win-win for everybody. And so the notion is, when this starts to go in, we as an industry and as people will start to change the way we look at air transportation. What does that mean? True point-to-point. I talked about this, the idea of door-to-door or point-to-point. I remember being at Boeing when we launched the 787, or back then it was called the 7E7. And we talked about being a point-to-point aircraft versus the A380. Well, yes, 787 is point-to-point if your one point happens to be a hub and your other point happens to be a hub. But if not, you're not doing point-to-point. It's maybe better than a 747 or an A380, but it's not even close to being true point to point. We will be moving into a future of transportation, especially now with COVID and post-COVID, where people want to fly from smaller airports that are closer to their home or office and fly to smaller airports that are closer to the destination. People will not want to drive an hour to a big airport, get there an hour ahead of time, stand in lines of security. They're going to want to come 15 minutes ahead of time, like you go on a ferry, 15 minutes ahead of time, go to the plane, grab a cup of coffee, get on the plane, fly to your destination, get off, and then drive 10 minutes to your destination. That's what people will want. The next step will even be they'll want to do it on demand. So to do that, the smaller the airplane and the lower the operating costs, the more likelihood this will happen. Guess what? Electric allows that to happen. We'll see a fit of equipment to mission. I talked before, our current industry says one size fits all. I will build the most advanced 737 or A320 possible, and you will use that to fly across the United States, across Europe, and across a fjord or a 100-mile distance. Why? Because that's most efficient for me, the OEM. So everything in aviation is supply-driven, supply-based. This is the plane I have decided to build, so you will fly it. This is the route I have decided to do, so you will buy tickets on it. We are going to move to a very different environment that says, these are the routes I want to fly. Where can I get a small, efficient plane that can do those routes so I can sell tickets cheaply and do it on demand? And so we'll see a switch of the business models there. The second thing I think we'll see is that there won't be competition or a decision between, do we use battery, hydrogen, synthetic fuels, biofuels? I think there's actually going to be a split of best technology for the route. For small planes doing short distances, battery is fantastic. It's good enough even today. Harbor Air, for example, as I mentioned, the eBeaver can do a 100-mile range, plus, of course, the emergency reserve, 100 miles in range. Now, that doesn't sound like record-breaking distances, but they do on average 60-mile range flights. And so 100 miles is fantastic. They sit on the ground between flights between 30 to 45 minutes. For a 30-minute flight, they need 30 minutes to charge. Fantastic. And so starting in the niche is really about who can operate it and get value, not can I meet 90% of the entire market? Because if we wait for 90% of the entire market, it'll be 2030. And so short, small planes, battery. Larger planes doing short or medium distances, we think will be hydrogen fuel cell. It will still be an electric airplane, except the electricity, instead of coming from a battery, will come from a fuel cell. Still the same. We're working, for example, with Universal Hydrogen. We're taking a Dash 8 airplane, a 50-passenger airplane, and we're going to together electrify it. We're doing the electric propulsion. It's a 2-megawatt class electric propulsion system, and they're going to do the fuel cell technology. And then I believe that at least until 2030, 2040, at least until then, the long distances, 1,000 miles or more, will be traditional jet engines as we know them today. But instead of using the dirty Jet A fuel that they use now, it'll be synthetic fuels or biofuels, something a little cleaner that will help reduce some of the emissions. But you won't be able to fly from Europe to the US on an electric or hydrogen plane anytime in the near future. So I think we're going to see a split into right technology for the mission. So I also like to point out, what can policymakers do? I don't know if there's anyone on the call here that's from local or state or regional governments, but there are things that governments should and can do in order to help our world become more efficient from an air transport perspective and cleaner from an air transport perspective. And what are policymakers really good at doing? Policy. So do policy, grants, rebates, tax incentives, etc. And there's a few key points that I think are really important. One, we should incentivize operators, airlines, that move to cleaner aircraft. So if you have an existing airline that flies, I'll call it a dirty aircraft, on a route of 50 miles, give them a tax incentive or a rebate if they decide to fly a clean aircraft for the same route. So you give them a benefit. If a new airline starts up, give them a benefit also if they start up as a clean airline. So that will incentivize them, because right now, the world of airlines is very complex and it's expensive. So people are afraid to start an airline, even if it's with a new low-cost clean aircraft. But if the governments can incentivize them, That's how you start that level of competition. If an airline starts new routes using clean aircraft, I think they should also be incentivized, at least for a period of time. Grants or help for airports to prepare for clean aircraft, charging systems, renewable energy systems, wind turbines, solar, etc. Then I think we can set as governments what I call aspirational policies. In fact, Scandinavian countries have already done this and are leading the world, and I applaud your governments for doing this because I think it takes a lot of guts, to use the right term, to do that, and they've done it. Basically say, all domestic flights will be 100% emission free by this date. But what I like to tell other governments who don't have as much guts, I said, look, you don't even have to go to that extreme. Even do something limited. All flights under 200 miles have to be 50% less emissions. Do something, because if you do nothing and you hope that it will happen, it will never happen because there's no incentive. So the idea is if you can set aspirational policies, that will drive the industry to move forward. And then, of course, setting clear aviation emissions. For some reason, the aviation industry is one of the only industries in the world that gets away with not measuring their emissions. It's terrible. I don't understand how this can happen. And more so, it's one of those industries where now IATA and the industry are saying, okay, we'll compare our emissions to 2005. We are much better than 2005. Who cares? I want to be better than today, not better than 15 years ago. That's not a good comparison. And so we need to set clear emission standards for where we are today and where we want to be 10, 15, 20 years from now, and not compare it to 15 years ago and take advantage of things that have already happened. That's not right. Finally, from a policy perspective, I think it's very important that our education systems have practical elements in STEM. And what do I mean practical? The most important elements that we see missing from university students, and it doesn't matter if they come from US universities, European universities, Asian universities, we hire from all of them. They're missing two things: practical hands-on experience and critical thinking. They really know the theories well. They know the algorithms. They know how to do analysis. They know how to do stress. But when they come into the real world and see a real world problem that doesn't fit the models that were studied in university, they get stuck. And then you have to help them, and that wastes time, etc. So having universities and high schools and middle schools, even children starting to learn practical, hands-on, critical thinking around STEM, science, technology, engineering, and math. If we take practical and critical thinking around those four aspects, I think we will have a workforce and leaders in the next 10, 20, 30 years ready to take us further. There are still challenges. So this would be clear, even though we're flying today, there are still challenges to make this mass adoption. One, of course, we all know, energy storage. The aspect of batteries, while we can use them today for niche, are not yet where they need to be, or hydrogen fuel cells, but it's being developed, it's happening. There's more investment today in these than anyone else. And it's happening not necessarily because of aviation, thanks to cars. Tesla and the other electric car companies are really leading this effort. We can use, and we use the same battery cells. We pack them, of course, differently for aerospace, but it's the same technology. So that's happening, and we need it to continue to happen. Certification, of course, is a gate that no other industry has to follow. It's a very robust, very difficult gate. We have one airplane now in the world that is certified. It's not full certification of a commercial airplane. It's still kind of like a light sport aircraft type certification, but it's a great move forward because it's a precedent that the regulators had to go through and show, yes, we can in fact give a certification of a certain type to an electric aircraft. So that's a great progress, and we continue to make progress. And by the way, on certification, I don't think we should get any discounts. I don't mean discounts on price. I mean discounts in requirements. I tell my employees, I tell new employees, I tell anyone I can, the job of the regulator is very difficult. The industry likes to say, oh, the regulator, EASA, FAA, it doesn't matter. They're very slow. They're not flexible. They're not innovative. I don't want them to be flexible. I don't want them to be innovative. I don't want them to be creative. I want them to make sure that when I say my motor is ready to put a plane in the sky and my children and your children are going to fly on it, I want them to say, yes, it's safe for your children to fly. They have a job that's very difficult. I've been working at this for a long time. My company's been working at this for a long time. By the time we get to 2022, the certification, we will know every single piece of metal, material, composite that's in that motor. Then we go to the FAA people and to EASA and say, please look at these papers and approve it for safety. Imagine the responsibility on these people's shoulders. It's very difficult. And think what happens when they do it wrong. We just saw with the 737 MAX what happens when it's not done correctly. So we don't want any discounts or any flexibility from certification. We want them to be very rigid so that when we do pass the gate and when others pass the gate, I feel comfortable putting my kids on that plane. And then finally is the ecosystem, distributed electricity, charging stations, etc. The nice thing about electric that I like, and it doesn't matter again if you're doing fuel cells, hydrogen, batteries, the nice thing about electric, there's a path to completely green, clean, renewable ecosystems. There are airports in Australia where we used to have offices that are already self-contained. They have a microgrid. Solar and wind create their own electricity. Oil, fuel will never be clean, no matter what happens. And so from that perspective, the beauty of the electric ecosystem is a path to complete greenness, but we have to continue developing it. So just again, to make clear, this is real. These are programs we're working on now. We're either already flying on 2 of them or working now on 3 others, and we'll be flying some of them already this year. And so these are real programs. It's really happening. So I just wanted to share that this is not just drawings. And with that, I'd love to open it up to a conversation.
Great, fantastic, Roei. Thank you very much for that presentation. I really appreciate also how you connect both the technical components to the wider, bigger picture of what it will mean and how it will change. Quite fundamentally, the things that we are used to, something we've been very eagerly discovering as well within the FAIR project. I also appreciate that you are so willing to open up for questions and that we have a little bit of extra time for that. We've done this before in the past, and I've always tried to moderate a little bit the questions so that it doesn't become a free-for-all and a bit messy for others to follow. I will try to do the same thing now. So I would like to ask people to raise their hand so that I can give you the word and ask Roei a question. But of course, I don't want to block any interesting discussions that will happen. So please feel free to respond then to answers. I think that is interesting for everyone. Lastly, I want to point out that I forgot to mention in the beginning that we are recording today's session and that it will be made public as a way to share the knowledge we are talking about today. If you have an issue with that, that is of course fine. Please, I will share contact details later on if anybody would like to say something. I see Matthias Lindström has raised his hand. Please, Matthias, go ahead.
Yes. Thank you, Göran and Roei, for a very interesting presentation, and it's very comforting to hear you speak and very inspiring, and it feels like our region and our project is on the right way when listening to you. Regarding this certification process, in your opinion, what is the single most biggest challenge regarding certification?
Fear of the unknown. I think that's the biggest challenge. Electric motors are not new. They've been around for over 100 years, right? We all have them at home. We're all used to them. Batteries are not new. We've been using batteries for years. We've never put electric motors with batteries in an airplane. And people are afraid, not consumers, regulators are afraid that on their shift, when they're the ones signing the paper, something will happen. Now, here's the sad thing about aerospace, and it's a fact. There will be accidents. It's unfortunate, but there will be. At some point, something will happen. And it could be for any reason, not because it's electric, but we live in an age where airplanes that have been flying for 100 years still have accidents, right? It happens. Very small percentile. It's the most safest mode of transport in the world. In fact, more people die on the way to and from the airport than the flight. But it still happens. And I think there's a fear on the regulatory agency side that if I approve this electric plane, and God forbid something happens, they'll say, you see, you approved it. And you didn't check this or this or this or this. Mm-hmm. So on the one hand, that's why I say, I don't want the regulators to give us any discounts. I want them to feel comfortable that this is a safe plane to fly, or as safe as any other plane can fly. On the other hand, I think the one, to your specific question, the one thing that's stopping progress is this fear of the unknown. And so my goal and my offer always to the regulators is, come to our facility, learn about electric motors. Come take a look at the insides, how it works, how it operates, where the faults can be, what happens if there's a short. Come play with it so they can learn. So we want the regulators to be able to learn and do whatever they need to feel comfortable.
Thank you.
Sorry, Arne, go ahead. I see you have raised your hand.
Yeah, I saw your customers, but what are they primarily interested in when they buy your product?
Oh, there's a few key things. One, and you saw that there's two types of customers. One are operators, like Sydney Seaplanes, like Harbour Air. These are airlines that operate the planes. They also happen to have their own MRO capabilities, and so they want to modify the planes. They're interested in two things. One, they're tired of paying very, 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 very high costs for all of their engine maintenance and for fuel. They're tired of it. They want to do low-cost operations so that they can do more operations and grow and provide more services. They're tired of paying high fuel costs, and especially on the seaplane, having fuel spill onto the water and create dirt and create emissions and noise where they fly. They're tired of it. They want to be able to offer their customers flights on clean, quiet, environmentally friendly aircraft at an affordable cost. That's one thing they want to do. The OEMs, on the other hand, like Aviation, like Faraday, like Universal Hydrogen, what they want is to be able to offer airlines these types of aircraft. Bigger, smaller, longer range, shorter range. That's already different purposes, cargo, passenger. But they want to be able to offer that so that airlines have that choice. So it's really, from our perspective, when we look at this, it's really not, we're not an environmental company. We're not Greenpeace. We're not doing this to save the world. We're doing this because electric aviation is such a compelling business case. It's so lower cost to operate for an airline, and an airline can operate more services at lower cost and offer lower ticket prices, lower package prices, that it makes sense. And a great benefit of that is that it's zero emission. So it's really about the economics of aviation. We want to change them, and our customers want them to be changed.
Thanks.
Great. Joseph, I see you've raised your hand. Please go ahead.
Hi, my name is Joseph Kahn. I'm the CEO of Lycksele Airport, a regional airport in Sweden. I have a question. Maybe you already mentioned this previously in your presentation, but I see that you have fitted an electric propulsion system to the Cessna Caravan. Is the plan to re-engine existing regional aircraft, or is the plan to develop new regional aircraft from scratch?
That's a great question. That's a great question. I'll start with the long term. The long term will be that the industry only has aircraft, electric aircraft, that were designed and developed to take advantage of electric propulsion. What do I mean by that? Take the cars. The first Tesla was actually a retrofitted Lotus. It had very limited range and capacity. Why? You take an existing car that wasn't designed to carry heavy batteries and electric systems. It was designed around a fuel system. And then you say, okay, where can I put these batteries? Maybe a few in the back, maybe a few in the front. So you're limited. Same thing with the plane. When we took the Beaver or the Caravan, we take a plane that's used to taking fuel and say, okay, where can we put these batteries? Maybe we could put some here, some there, so you get a limited range, 100, 150 miles in range. Then Tesla said, now that we know this works, let's design a car that's designed around the battery. So the entire floor is a big flat battery, etc. So now you can take 5 people, 400 miles in range. Same thing would happen with airplanes. 9 people in a Caravan electric can fly 100 to 150 miles in range. 9 people in an Aviation Alice can go 500 miles in range. Why? Because it's built around the battery. It has designs that are much more efficient for a small, lightweight propulsion system that you cannot do with a piston engine or a turbine engine. And so the future will be electric with electric designed aircraft. But to get there, we don't think people should have to wait. Some airlines are happy with 50, 60 miles of range. If you're just hopping between fjords, maybe you don't need an airplane that can do 500 miles. Maybe 50 miles or 100 miles is enough. Then why spend money on a new airplane if you can spend less to retrofit? Maybe some people want to start in 2022 and not in 2025 or 2026 when Heart Aerospace will be available and Faraday will be available. Maybe they want to start earlier. So why wait until these electric planes are ready? Let's have a retrofitted electric plane. You get the same benefit, lower cost, zero emission. You give up some range and payload. But again, depending on what you're trying to do, that's why I think the short term, the next 5 to 10 years, we will see retrofits and more electric starting. And then 10 years from now, we'll see less, if any, retrofits, but all electric designed aircraft.
Very good to hear. Isaac, go ahead.
Yes, thank you. Isaac Brenström from the FAIR project. I also want to thank for a very interesting presentation. And I was just wondering about you are certifying your products for the North American standard, I guess. And are you applying for certification in European market as well, or are you planning to enter the European market anytime soon?
Yeah, so we're starting with the FAA just because we're here, and the FAA is the largest aerospace market. So we're just starting here for convenience. It's the simplest, but we do plan to expand that to other regions and countries. For example, and we do that with launch customers. So for example, Australia Pacific, we've now launched with Sydney Seaplanes. They're going to do the certification, the STCs of the, in this case, the Caravan first, down in Australia, the Pacific. And so that way, in the UK, we're doing with Faraday. So that way, once we have a launch customer, and it doesn't matter on what type of aircraft, retrofit or new design, then we immediately start to work towards parallel certification.
Lars.
Okay, yeah, thank you very much for a very good presentation. Really enjoyed that. And in the beginning, you were into this with the door-to-door time here for flying, very important. And we also touched or was on this relation that I've found interesting between the airplane, the airline, and the airport. Because if I haven't misunderstood, I mean, if you look back in the history here in Scandinavia, then we had smaller airplanes in the 70s, 80s, or still in the 90s, I think they were traveling here. But then for different reasons, they were moved out. And now it's only small charter companies. So it's no regular timetable routes with smaller ones. And the story goes that the cost, it was not the airplane, it could be it's partly the airplane cost, but also the cost for the airline of having regular traffic, so to say, and the airport cost, so the landing fees and everything around it, that forced them to go up in size, to have larger aircraft. It was not possible to have a fare that was competitive with smaller airplanes. So my first question, is that also something you can agree upon, or do you think it's a misunderstanding from my side on that?
What you're saying from my point of view is partially correct. In 2005, 50% of airline flights were done with planes less than 50 passengers in size. By 2019, that was less than 20%. So you're right, the airlines are disappearing with small airplanes. The reason is airlines have figured out that given all of the operating costs, be it fuel, maintenance, airplane capital, airport, all of the fees, operating airplanes is so expensive that the bigger the airplane, the more money they make per passenger. That's what airlines figured out. And OEMs figured out the same thing. The bigger airplane I sell you once, the more money I can make. And so the industry moved to bigger and bigger airplanes because per seat, that became more profitable. But per person, that became less convenient. Now you have to wait for one big plane as opposed to get multiple small ones. Imagine having to go by bus versus taxi. Now, today you might say, if the bus is more efficient, lower emissions, etc., and is cheaper, then maybe I'm worth waiting. But what if the taxi was the same price as the bus? Who would want to go on a bus? You have to go to the bus station, go with all the other people to all the stops, get to the other bus station, and then leave. The bus is, of course, more efficient from a system perspective, but less convenient from a personal perspective, especially if you have to take a taxi to get to the bus stop. And so from that perspective, airlines have figured out the bigger the plane, the better. But it's worse for the environment. It's worse for people. It's worse for flexibility. And all these small airports that maybe wanted to make some money from landing fees now don't make any money because no one's landing there. So I think if you look at what the true equilibrium will be, is that when you have smaller planes flying in and out of smaller airports and you distribute that demand and supply. Right now, for example, here in Washington, they're talking about requiring another major airport. Why? Because this major airport is full. But if you take out all of these little flights that are done by big airplanes and you move them to the regional airports where actually people live and they fly in and out from, suddenly the big airport that's really good for long distance can become more available. The smaller airports that are not even being utilized can be utilized. And when a small airport suddenly gets 1, 2, maybe 3 flights a day in, maybe they want to open a restaurant. There's some jobs and some economic development. Maybe they want to offer a little store to sell something. Maybe a few more taxis or Ubers or Lyfts or electric transport, maybe in the future driverless, will show up. And so at a very small scale, but still at scale, every one of these little airports can suddenly get a little bit of a boost to its economy at the expense of the big airport that still has to do long-range flying. So I think if we do this correctly, it's actually a win-win for everyone. The reason it hasn't been done until now is that these small planes are very expensive to operate relative to what you get in revenue. But if they're electric, and instead of paying $1,500 an hour, you're paying $300 an hour, suddenly it can become worthwhile.
So if I just add that, so when you talk about, if I understood it right, that you lower the cost of the airplane per hour with 40 to 80%, what will that be on the fare? I mean, then you have cost on the airport or so, or do you think that we can introduce efficient small airports with efficient small airlines that can offer regular traffic? I mean, currently it seems that the small aircraft and airlines, they have charter, so to say, because the step over to regular is so costly for them.
Right. It's costly because operating these small airplanes, let's say you have take the Caravan. It's a 9-passenger to 11-passenger plane. It costs about $1,500 per hour to operate. So if you can take 6 people on that airplane, divided by $1,500, that's at least $200 per person for a 1-hour flight. That's a lot of money. But what if the Caravan costs only $400 per hour to operate? Now you're looking at $70, $80 per person for an hour flight. That's actually reasonable. And so now the question will become for the airlines and the airports, are they greedy? Meaning they'll say, oh, now that I can get more profit, I'll increase the price of the ticket and I'll get more profit. And then the airport will say, oh, I want now more profit. And so everyone becomes greedy. And so the efficiency goes down. Or do they say, does a small airport say, I can have 0 planes coming to my airport, or I can have 5 planes coming, and I'll get to benefit maybe from some landing fees, from some restaurant revenue, from some electricity revenue, and I get something. And the airlines say, I have now a 40% discount in my operating cost. I'll give 20% of that to the customer, 20% I'll keep and expand my network. Everyone's a winner. Whether that's done or not is really not up to the manufacturer. That's up to the airlines and the airports. But I think in this new world, if they think about what's right for society and what's right for the economy at large, it will come out to be a good proposition.
Okay, actually, I'll stop there. But thank you. I think I do really agree with your thoughts here. And I think the route we're talking about here over the Kvarken Sea here is very suitable to this type of flying. Thank you.
Very, very interesting. if I can jump in there just to sneak in, because I have that position as a moderator, I just want to ask a follow-up question a little bit. I'm quite curious. I am a design researcher, so I'm in this project with wide eyes and learning a bit about electric aviation and exploring this topic. And I'm quite curious about two things that I would like to ask you. And the first one is, from your experience also having worked for Boeing and being in this industry for some time, I'm quite curious about how do you imagine the bigger established industry is watching these developments, whether it's the airline manufacturers or the airlines themselves, because I've found so far that they are in some ways, in some venues, conspicuously absent from the discussions I've been seeing around this electric aviation. But happy to hear your thoughts on that.
Yeah, it's interesting. You guys might remember a company once that led the photo industry called Kodak. Remember that company? And they're gone because they weren't willing to see the future. No one will use digital camera. People like to see pictures. Film is much better quality. People like to have a picture in their album. No one will do digital, even though Kodak's R&D lab developed some of the first digital cameras. And they weren't willing to see the future. They weren't willing to accept the future. They weren't willing to accept that they might have to lose some on film in order to move to digital. And today Kodak is gone. I hope that that's not the future for many of the OEMs, because there's some great companies, Boeing, Airbus, Rolls-Royce, Pratt & Whitney, GE. These are great companies that have been doing amazing things for aerospace, but they have become fairly complacent. In the last 70 years, or the last maybe specifically 50, there has been no real development in aerospace. There's been some incremental development, a little bit of improvement on engines, a little bit of improvement on aircraft, winglets. We get excited when there's 2% gain. Oh my God, this is unbelievable, 2% fuel reduction. Why aren't we doing 50% fuel reduction? Why aren't we doing 70% fuel? Why are we excited by 2%? Because there's a very set number of companies who are comfortable where they are. Now, I don't mean that as a bad thing. It's not that they're bad people or they're trying. It's just a position that it's very expensive, very long, very hard to create innovation when you have existing customers, existing products, existing technology that you're trying to do. I don't know that I would act any differently if I were the CEO of Boeing or Rolls-Royce. I would hope so, but I don't know, right? It's much easier to do something when you have 60 employees and no brand to lose and no existing products to lose than when you're leading a 100,000 employee company and 100 years of history. I hope I would do things differently, but I don't know. So that's one aspect of it. It's very hard for large companies to give up what they currently do, what they call the cash cow. So that's one. Two, mentally, culturally, it's hard for large companies to innovate. Large companies, and we're not talking about 5,000 people, we're talking 50,000 people, 70,000 people. These large companies are built to succeed around process, procedure, given guidelines, and the average employee. If you have 50,000 employees, you can't have everyone above average. It's impossible, right? It's just not doable. So you do this with process procedure. The process and procedure is anti-climatic or anti-innovation, because innovation happens without process and procedure. You can't process your way into innovation. Now, you need process procedure for safety of flight, for quality, etc. But to do the true innovation, you have to step outside of it and say, what if there were no rules? How would this look? And a big company that's successful because of its rules cannot do it. There have been multiple attempts at all these big companies to have incubators, and people talk about, oh, I have a startup inside of the company. No. When you know that even if you fail, you still have a job, that's not a startup. That's not innovation. Innovation spurs from the knowledge that if you fail, people go home without work. They can't pay for their home. They can't pay for their children's food. That puts an urgency on the cultural aspect of people to say, this must be successful. If not, I don't have another job to go to. This is it. It's a very different perspective. So that's the second reason, is the cultural aspect, which is why I think big companies shouldn't pretend to try. Let little companies do it and then go buy it and bring it in to the process. Now, specifically, I don't talk about magniX or aviation. We're not a company looking to be sold. We, in fact, want to become in the future one of the main aerospace companies. So it's a different perspective. But so we're not, venture-backed. We're not looking for an exit or something. It's a very different viewpoint. But from a big company's perspective, I believe they should maintain where they are in terms of we build, we integrate, we do these large things, and we know how to use the right rules, the right process, and then let's go get a technology that someone else has innovated. But there's a third reason today that we're seeing all of these big companies absent, as you mentioned. They're struggling to survive. You look at a company like Rolls-Royce, and I specifically pick them, one, because they're an amazing propulsion company, but two, they bought the Siemens electric motor propulsion, right? So from that perspective, they bought that Siemens division, and so they have electric propulsion inside of them. Rolls-Royce is struggling to survive as a company. Forget electric aviation. They're trying to survive as a company between the Trent 1000 problems and COVID and what this means to your revenue. If you look at the number of people they're laying off, they're trying to get more money to survive. Do we really expect a company like that to be focused on spending money innovating on electric? They're trying to stay alive for the next future for the rest of their divisions. The same thing you look at Pratt & Whitney. Collins or Raytheon just announced significant layoffs again from Raytheon, Collins, Pratt & Whitney because of COVID. And so do we really expect them to start to innovate and hire people to look at electric? They're trying to survive. These electric companies were lucky in COVID. I didn't lose any revenues because of COVID, because I wasn't expecting to get any revenues this year, because I'm a startup that was only expecting to get certified in 2022 anyway. So I was lucky that I didn't get hit by revenues. I was already operating from a mentality of, I don't have money, so I need to be very efficient, very lean. There's no fat in our company. People call me and say, oh, Roy, we'd like to schedule something, a meeting with you. Can we talk to your secretary? And so, oh, you're talking to the secretary. I do my own schedule. We don't have the luxury of all these things. Is it the most efficient? Maybe not, but we don't have that money. And so when COVID hit the airline industry, we were not hit as much. Heart Aerospace wouldn't have been hit as much. Faraday was not hit as much because we were planning for revenues in the future anyway. And so from that perspective, the startups had this great advantage at this time that the bigger companies, unfortunately, are suffering from.
Great, thank you for that answer. I'm sorry for cutting in line, dear friends. I'll promise I'll try not to do it again. I think Frederick, you've been raising your hand for quite some time. Please go ahead.
Oh, thanks a lot. Roy, thanks a lot for your great presentation. I've been following you, of course, and magniX for a long time. I think we've met online somehow as well.
Yeah.
But just a question about the technology, the further, let's say, efficiency gains that we can still have in the industry. I'm thinking about automation and moving to single pilot systems, especially in this kind of new aviation. Is this a road that you are looking into, and are you already discussing this road with regulators over there?
We are not. As I mentioned, we are very focused on propulsion. Whether there's 10 pilots, 2 pilots, 1 pilot, or no pilot in the front doesn't change the propulsion. And so we're very focused on propulsion. I believe that electric propulsion will come to market in aerospace and cars, and we've seen it, but the aerospace as well, before automation does. At the end of the day, as much as people might fear a battery fire, I think they fear more not having anyone up front. Now, most people maybe don't realize that once the plane takes off, the pilot hits the auto button anyway, and the plane flies itself, lands itself at the airport, etc. But I think automation will come as a step behind, although it will come not far behind. There are already companies working on that. So when we work on our electric propulsion system, we make sure that it's ready to talk to, if you will, or communicate with whatever cockpit system is in the aircraft. A fly-by-wire system like is on the Aviation Alice will be the first step towards automation, because you'll need fly-by-wire to really do full automation. And so we're preparing the propulsion system for that and getting ready for that step, although we ourselves are not doing it.
Very clear. Arne, you have another question, I see.
No, I think it's Simon. I just didn't take my hand down.
Okay, go ahead, Simon.
Oh, thank you. And thank you, Roy, for a nice, interesting presentation. I was wondering, what sort of infrastructure on the ground do you need in terms of charging? What do you need the airports to provide?
Yeah, so we are specifically, we and Aviation, the aircraft company, are using current car or vehicle standards. We're not trying to invent anything new, so we're using the standard car chargers. And I'm assuming, excuse me one second, I'm assuming that many of your airports, given that I know the percentage of electric cars being sold in Scandinavia, I'm assuming that many of your airports already have electric car charging capability. I'm assuming that's probably a fair assumption. And if they don't, they probably will very soon, because many of the people flying, either charter or commercial, probably come with electric cars to your airports. And so it's the same charging infrastructure. Of course, the more powerful the charger, the better. If you have something like a Tesla supercharger or any 400 or 500 kilowatt charger, then the charging time for the airplane will be quicker. But even a 200 or 250 kilowatt charger will work fine. The more you have, the more flexibility you'll have. But if you remember back to the discussion around smaller airport to smaller airport, we don't expect to have thousands of these electric planes suddenly flying in the air. To, you know, where you see like these videos of the air taxi, hundreds of them flying over cities. I don't think that's going to happen, because if you look at the small regional airport to small regional airport, that will be a subset of the people flying. So how many people will fly from your specific airport to another specific airport? So maybe there will be 1, 5, 10 flights a day, but it won't be hundreds of flights a day of these giant airplanes, right? You're not going to replace the main airport in Stockholm. You're going to offer regional flying. And so you don't need 1,000 chargers. You need maybe 1 or 2, maybe 4, but these are the same as the car charger. So maybe you can get them in discount when you do it. You already have the electric infrastructure. And so from that perspective, that's all we need. Nothing special beyond that.
Thank you.
Good. Andreas.
Hello, I'm Andreas Forsgren from the FAIR project, and thank you for a nice discussion and a good presentation, Roy. I would like to get back to the policymakers. I guess you have some intelligence on a global level out of your position as a startup. So, I mean, in Scandinavia, electric aviation is kind of a hot topic right now, and I'm a bit curious of how it is around the globe. I mean, I've heard about Australia, but I'm keen on knowing about the US and Canada as well. Also, I have a more direct question about refitting of engines and the cost of that. Perhaps you don't have it in dollars or like that, but as a percentage of the aircraft cost or something like that.
Yeah, so from a policy perspective, I will say that unfortunately, at least up until today, the US has been very much lagging when compared to Europe when it comes to environmental issues and definitely aerospace issues. The airline and current aviation lobby or industry is very strong and has been able to stay out of the whole environment conversation. I think that's wrong. I think that's not okay that we allow that to happen. And I'm hoping that today with the new administration, the new government administration in the United States, that have already started to talk about more harsh and more aggressive climate moves, I'm hoping that we'll see some new policies come into play. At least things like measuring carbon emissions from airplanes flying in the US today and seeing what the harm is, what they're doing, comparing them to last year, not 15 years ago, but compare them to last year, compare them to this year, and set a target for a few years from now. Will that be difficult for the industry to answer? Of course it will. But any real success and any real movement will be difficult. If we expect it to be easy, then we're not setting aggressive policy, right? No different for a country than for a company. If I set easy goals, we won't make a difference. If we set aggressive targets and aggressive goals, and we even get close to them, we've already made a big difference. So I think the US government has to do that very, very strongly and very aggressively, just like Scandinavia did, right? Can you achieve all domestic flights to be all electric by 2040? I don't know. 2040 is far away, but it's not that far away. Can it be done? I don't know. But I know that you'll have a better chance of doing it than any country that hasn't put that policy in place. Because why try? In Scandinavia, you have to, so you'll try. So even if you get to half of the flights or 75% of the flights, and even if it's not 100% emission free, it's 70% emission free. You've already made a huge difference. And so from that perspective, I really hope, and we're pushing for the US government to follow suit and do something similar. In terms of the cost of the retrofit, if you look at, we're trying to make it equivalent to the cost being spent today. What do I mean by that? If you have to buy today a high-end, high-quality aircraft that can take 9 to 11 people, we want the price of the electric aircraft equivalent to be about the same. Then you get to benefit from lower operating costs. If you're doing a retrofit, we're doing a retrofit on airplanes that every 2 years, every 1 year, every 3 years, depending on who they are, have to do a major overhaul for the engines. These are very expensive. They're about 80% of the cost of the engine. So we're trying to make that about the same. It'll be a little higher because there's also the labor involved, but we're trying to make it about the same plus minus. Much easier. I can do an overhaul, and then I know that I have to do an overhaul in 2 years, then in 2 years after, then in 2 years after, and I have to pay fuel and oil in the middle, or I can do a one-time electric and I'm done with all the rest. And so we're trying to make it equivalent to where the operators see true savings, not 5 or 10%, but 50% savings in their operation.
Thank you. Very good answer.
Great. I see Joseph from Lycksele Airport has raised his hand again. Please go ahead.
I have one more question. And as the introduction of electric aviation is a rather revolutionizing and significant change in the aviation industry, can we expect different changes when it comes to flight training, like lower hour requirements, and maybe a different license? What's your take on that?
I don't think it should be a different license. Why? You're still carrying passengers. Why would we make anything easier? Flying a plane is flying a plane. The responsibility a pilot has until it's pilotless, as Frederick was alluding to. But as long as there's a pilot in front, why would we expect them to get any less hours? It's still the same responsibility, right? There was a joke once, I remember, that the cockpit of the future will be one pilot and a dog. The pilot monitors the system, and the dog makes sure the pilot doesn't touch anything. And so if we think about that, even with the planes being much simpler to fly today, the pilot really is responsible for what happens if something goes wrong. Then why would we want them to have less training? I don't think that's something that should happen. They should have the same quality of training and the same requirement. But maybe for 9 or 19 people and for a short route, there can be one pilot instead of two because of reliability aspect, safety aspect, short range, you're always closer to an airport, etc. So one pilot instead of two, I think, is something that's very reasonable to go through, especially with the advanced cockpits of today. But the pilot training, I don't think should be any less.
Clear. Ida, please go ahead.
Hi, I'm Ida Norberg from Biofuel Region in the FAIR project. I have a question about the expected lifetime of your propulsion system.
Yeah, so we're right now designing for 30,000 hours.
Okay, do you have any second life for the engine? Have you any thoughts about that?
When I get to 30,000 hours, I'll tell you. Well, our expectation is, because remember, we've been operating them for thousands, but until you have thousands of these propulsion systems flying in the field, it won't be reasonable for me to say yes or no. But here's what I can say. If we look at the auto industry, electric cars are driving today far beyond what the manufacturers estimated they would drive, both from a propulsion package, the motor of the car, and the batteries. There are Teslas driving today with over 100,000 miles when people thought they would go 50 and have to replace the battery. And so from that perspective, what we're learning is that, for example, when we talk about battery cycles, 0 to 100% charge back to 0, no one does that, especially in aviation. When you have to maintain some battery for reserve by law anyway, then you'll never get to 0 battery. So the battery life will extend. The motors are very different from car motors. You don't do on, off, all the time. You turn it on, you fly stably, then you turn it off. And the electric motors are much more reliable, less moving parts, as I mentioned, much simpler, etc. We expect that the overall life and cost from a maintenance perspective will be so much lower that after 30,000 hours, even if you just want to buy a new one and replace it, it will make sense, or we'll have to do a check and then continue working. Just like, by the way, if you look again at appliances at home, they work for years without any issue. And then 10, 15, 20 years after your washing machine is done and you want to buy a new one, it's so reasonable from a cost perspective. You don't think about, oh, maybe I should just change the electric motor on my washing machine. No, let's just change it. And so it's gotten to that point that we believe in the future, electric aircraft will be the same. The propulsion will be so simple to operate, so simple to maintain, so simple to keep, that there'll be no reason to change it. Or if you do want to change, you'll just change the whole thing because it's simpler. Now, time will tell if that's in fact true.
Okay, thank you. But what is if you compare it to the conventional system today, is 30,000 hours, is that more or less?
Lots more. Right now, we're looking, for example, at 10,000 hours time between service, 10,000 hours. Today, for most engines, it's 2,000. Maybe there's even checks at 500. And we're looking at 10,000 before you even have to look at it. Now, whether the regulatory body approves it or not, I'm assuming that in the first years, EASA, FAA will want us to check even more than regular motors because it's new. Hey, check that everything is connected. Check that the cables didn't come loose. Check that the batteries are still okay. And that's okay, right? They'll want us to check it's new technology, just like they'll want to check new cockpits or new landing gear. That's fine. But as it grows in the industry, I think it'll be proven that less and less, and eventually maybe none, will be required. And that's significantly better than any internal combustion that is today. If you go to any airline or talk to any airline and ask them about how many spare parts they have for their engines, if not even a whole spare engine in their warehouse, because things always break and happen, it's amazing the amount of money spent in this inventory. With electric, that will go away.
Thank you.
Very clear. I see we have another question from within the FAIR project. Helka, go ahead.
Thank you. Hi, I'm Helka Kalliomäki from the University of Vaasa from Finland, and we are studying regional effects of electric aviation in the FAIR project. And I'm thinking about the discussion here in the Nordics, that there's quite an active discussion related to the possibilities of electric aviation when it comes to like balancing regional development and developing small and medium-sized cities. So I'm interested in hearing how is the discussion in the US. Are there some maybe interesting examples that we could study, like that, some regions that we could benchmark on, some interesting bottom-up initiatives, for example? It would be interesting to hear your thoughts on this.
Yeah, that's a really good insight and a really good point. And we talk about that a lot. Now, of course, electric aviation isn't prominent anywhere yet. And so there's no good examples of, oh, look here at what regional aviation, electric aviation did. So there's no examples. But with that said, what we're seeing are a few things. One, where before, up until COVID started, and COVID really, I think, will be looked back as a momentous change in cultural behavior when it comes to work. Up until COVID, at least here in the US, there was this great movement of what's called gentrification. All the young, higher paid, high-tech people coming into the cities, Seattle, San Francisco, Los Angeles, New York, and coming in there because that's where the big software companies were. They come in, they get paid more money, they want to live close to their work because as the younger generation, they don't want to own cars, for example. They want to be able to walk to work, walk to the restaurant, and so they come close to work. They pay more rent, they increase the price of houses. Other people have to move out because they can't afford it anymore. And there was a big movement around that. Now with COVID, suddenly a lot of these companies are figuring out, people can work from home and they're as productive, maybe even more productive. So you know what? After COVID is done, stay at home. Amazon, Microsoft, many companies here in the region have already told employees, even after the rules have been really relaxed, at least until the end of 2022, we expect that you can continue working from home. So now we're starting to see a movement out of the cities. A young family can suddenly, for the same money as a small apartment in downtown city, can buy a nice home with some property in a town farther away. Because now they don't have to come to work every day. Maybe they have to come to work once a week or once every 2 weeks. Imagine if instead of driving 1 hour, which people do commute today anyway, and instead of living somewhere where you can drive 2 hours, you can fly 15 minutes. Imagine living in a small town, fresh air, no congestion. Your money is much more than what it is in the city because you're still getting the same salary. But you can buy nicer home, afford nicer things, have a better quality of life. And every week or every 2 weeks when you have to come to the office, take an electric plane from the airport nearby. You take an electric car that will take you to the airport, fly the electric plane, get on a little electric scooter or bike that will take you back to your office. And you do that once a week, once every 2 weeks, and then you go back home. Imagine the quality of life that happens. Now imagine what that does to those little towns. Suddenly, those little towns that were once considered remote villages suddenly have people with higher income coming there. They'll want to buy more things, maybe more restaurants pop up, more factories, and I mean factories in producing some more clothing, more transportation, maybe a hotel or two. Now, it won't be suddenly that these small towns will become a big town and have all the problems, right? It's not going to happen because, again, you're spreading out from one city to multiple towns around. And so it'll be a little bit in each, but each one of them will have that growth and that prosperity that comes with it. On the flip side is also true. Today, if you have a small company, a small factory in one of these small towns, and you want to sell your things, you have to either, for example, if you're here in the US, the only way for you to ship those things on demand, which is what people say, is to go on Amazon or Alibaba or one of these big platforms. That means you give up a lot of your profit to be there. That means you're one of many, and you maybe lose your identity. And taking your own truck or transportation system is very expensive. But imagine if there were small electric planes who could come to the airport near your factory or near your operation, and together with a few others, you could ship overnight or same-day delivery your packages to the big towns nearby. Suddenly, as a small, what we call mom and pop factory or company, you can suddenly start to share more. I'm not going to say you suddenly become a global company. No, let's not pretend that electric aviation will make the small company in a small town a global competitor. But it will allow them to expand their reach beyond driving distance and in terms of speed beyond 2-day, 5-day delivery to same-day delivery. Imagine now what that does to that company. They can hire more people. They can grow. And so the prosperity we believe in all these small towns will definitely go up.
Really nice to hear, Roei. I think that there's a perspective that's very valuable and one that we are is very relevant also for Scandinavia and especially the north here where we are, and one that we are exploring very actively in the project. I don't see any raised hands, but I do invite you to ask that question that is burning a little bit. I see Arne has one. Go ahead, Arne. Or not?
You were talking about some drivers in the society, but you have some different. But what the key drivers? What do you need to open up the interest for electric flying? If you can choose what you want, the best one.
Yeah, if I can choose, I want policymakers to take an active role. That would be my choice. Industry will follow. Industry, the technology will be solved. Industry will follow. Policymakers should do it. I'll give you a simple example. When electric cars started to get introduced, the state of California made a law for California. That's the only thing they can control. They made a law that says 15% of any type of car from a manufacturer sold in the state of California must be electric. Made a law. Any manufacturer. And so suddenly, in California, you can buy types of electric cars that here in Washington can't be sold. I'm not saying in another country. Right next door. In California, you can buy an electric Mini Cooper. You cannot in Washington. In California, you can buy a Fiat 500 electric. You cannot in Washington. Why? Because California made a rule. Washington did not. And so the manufacturers are pushing to say, let's go to where the rule requires it. And they make the investment. So industry will follow where policy leads. Unfortunately, policymakers are very, very many times afraid to make policy because they think not everyone will be happy about it. So what? That's your job as a policymaker, is to look to the future and make the future a better place. So if I had to choose one thing, it would be that policymakers take an active role in promoting the need for, it doesn't matter what you call it, electric, call it low emission, but do something to require that this happens in your region, in your country, in your sphere. And if that's required, industry will make it happen.
Do you have any contact with the local policymakers in Washington State then?
Yes, I do. There's also another big company in Washington State that makes very large gas airplanes.
Okay, and they have a bigger budget on the opinion.
Sometimes that's how policy works, unfortunately. So we try slowly but surely to push.
Yeah. Thank you very much.
Very, very interesting, and also very relevant again for the project we are doing here and why we're gathered here. Does anybody have a last final question for Roei? I don't think so.
Right. Well, thank you very much. It's been a pleasure.
Thank you very much, Roei. It's been a pleasure to listen to you sketch not only the technical perspective, but especially also the bigger point of view that emanates from there. I really appreciate that you've made the time so early in the morning to share that with us, and we hope you have a great day. I'm just going to close the session with a few remarks about the project.
Thank you very much, everybody. And if there's any follow-on, feel free to contact me online or feel free to call me. Thank you very much.
Thank you.
Thank you, Roei. Let's see. Having some issue with Teams right now. Hang on a second. Okay, well, that's not working. I think you have all the information that I wanted to share with you anyway in your email from the invitation of today's session. Thank you all for attending. We will continue to hold these webinars quite regularly, and you are all on a mailing list now, I think, so you will receive more information. For information about the webinars, you can contact Carita Roslund, who has also been mentioned in this invitation. And you can find the FAIR project also on LinkedIn with the website FAIR. That should also provide you with the opportunity to contact anyone you would like in the project. The message, once again, is that we are very open for collaborations, discussions, points of view that can contribute to the knowledge we are developing together within the project. So please feel free to reach out, and hope you all have a great day. Thank you very much.